Recording is underway. I see Deidre joining us. And I'm going to go ahead and share the screen so that I can make sure I got this thing set correctly. Nope. I can't tell what's top back on this thing. So, now then I should be. Drawing. Now I've got to figure out why it's not drawing. Okay, it's drawing now. And let me mark Deidre here. Let's see if anyone else came in the midst of that. I think that's it. Okay. So now I'm going to go ahead and we're going to roll. I want to talk to you today about subnetting and show you, go through a short little demonstration on that. It's going to take the whole hour based on last hour when I did this morning. And I would love to take longer and show you some more, but I'm going to try to cut it off at an hour. What we're looking at is the general term subnetting. But what is subnetting? Subnetting is taking a network and breaking it into smaller networks so that then you can manage it better. And it's something that has a lot of work involved in it in IP version 4. When we get to the next chapter in IP version 6, you're going to learn there's nothing to it in IP version 6, that you don't have to do all of this calculate and everything else. We're going to be basing this off of what I already taught you about number systems and about your column values in binary, because we're going to be converting our decimal numbers to binary and then converting them back to decimal. And then we'll see what are our usable addresses for each of these subnets. Now, when you do subnetting, you do lose some host addresses. But you've set it up where you can manage it better. So anytime you do something that helps, usually that does something that does some harm to whatever it is you're doing, and that you got to find the balance on it. And that's the key on this, is that by subnetting, you get to have better manageability, but you lose number of addresses. So that's where we're going to be coming from. So I'm going to go through, I want to do two things today, basically three things. The first two are very closely related. I'm going to teach you how to subnet a network, both based on number of subnets that you want, and also based on that you were given the number of hosts per subnet wanted. So two approaches on that. The other item that I will touch on at the end is looking quickly at an address and being able to pull the network address out of it. The book takes an approach of using ANDing to do that and gets rather complicated on it, in my opinion. And so I'm going to show you where I think you can do it a whole lot easier and get the same information. Now, if the ANDing makes sense to you and you like that, use it. I'm not saying anything against using ANDing. I just think doing ANDing just complicates it more than it needs to be. If you really want the full explanation of how you're really doing this and all of that from a mathematical viewpoint, then yes, you want to do the ANDing. But generally, my students and me are not mathematical people and looking to have every little explanation in mathematics, and having been ones to take lots of calculus, etc., but just want to know how it works. So that's the approach I'm going to use. Now, I've gone a little bit further in math, No, I've never gotten to calculus. I've gotten to pre on that, but I've never taken calculus. But I like doing some stuff in math, but the advanced math, forget it. It's beyond what I really like getting into. I'm not saying I can't do it. It's just I'm not interested in doing it and have not had a demand to do that. So where I'm going to go from now is that first I'm going to show you, and oddly enough, I'll be doing the same demonstration tomorrow afternoon for the North Carolina Computer Instructors Association, the North Carolina CIA. On that at 4 o'clock tomorrow, I'll be doing this, doing a presentation about how to do subnetting. At 3 o'clock and at 11 o'clock tomorrow, I'll be doing presentations for them on how to work with number systems, which is what your lecture you had a few weeks ago when I taught you about how to go from binary to decimal and decimal binary and what hexadecimal was. But oddly enough, it hit on exactly the same week for me, for them. So where I'm going to go from to start with here, and I got to get my pointer back over onto the, oops, I didn't mean to draw those lines right there, but it did. So the first thing we're going to be given is I'm going to get an address, 192.168.3. No, let's do something different. 4.x. And that's my network address that I have been given. It's a Class C address, if you remember from earlier this week, and that there's a possible 250 hosts associated with it. It has a broadcast address and a network address. The network address is all zeros in the host portion. And in this address that we actually have, 3 parts are the network portion, and then 1 part is the host portion. So that will be on that. So we're going to be actually working into the host portion. The subnet mask that's assigned with it, which is the default one for this address as a Class C. It happens to be a private address, but we could have easily used a public, but you generally like to demonstrate with private so that it's not a real address and keeps things from getting goofed up somewhere by people that a little knowledge is harmful. So there's our subnet mask that we've been given. Now I want to get 13 networks out of here. So I want 13 subnets. Okay, is what I'm wanting to do. I want to split it into 13 subnets. And that's what I'm going to demonstrate to you right here. Okay, now to do this, if you remember when I taught you how to do binary, I taught you numbering from the right to the left so that you had your column numbers 1, 2, 4, 8, 16 going from right to the left, just like your ones, 100s, thousands, and decimal. For this purpose, purely for determining how many bits we're going to borrow, because what we're going to do, so let me get our 8 bits. That makes this last octet here. And I just lost count. Okay, 7, 8. So I'm going to be working in this octet, which is the one that's labeled X up here. So the first thing we got to do is determine how many bits are we going to borrow to use for the networks. Because now we're going to take bits that should be host bits, but we're going to borrow from them to extend our network further to be able to have subnets within the network. So we're going to be borrowing a certain number of bits. Now, for determining the number of bits you're borrowing to, based on being given the number of subnets you're to have, we're going to do a reverse number. This is the only time we're going to do these reverse numbering on the columns here in binary. So I'm going to start numbering them off, and notice they're the same thing as I told you before, except I'm going from the left end instead of the right end. So now my object is to get to a number that's bigger than the number of subnets I need. So I've got the 1s, the 2s, the 4s, the 8s. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. Well, 15 is greater than 13, so yes, if I borrow 4 bits, I can make 15 subnets. Okay? Actually, I can make 16 subnets because the 0, 1's not counted right there. If I only borrowed 3, then I'd only be able to make 4 plus 2 plus 1 is 7, plus 1 is 8. Well, 8's not 13, so that's not going to do the job. So I'm going to have to borrow 4. So I'm going to borrow to here. So everybody got that part so far? And somebody just joined in, I thought. Looks like a couple of people joined in without me knowing it. Okay, I see who I need to add, and that pen's not going to work because my marker pen for my pad's not going to work on a piece of paper. Okay. Does everybody follow how I've decided to borrow 4 bits? Now, next thing let's come up with is our subnet mask for this. Yes, this is the only time you're going to go in this reverse order on it. This is just a special situation. So normally you always number them from the right to the left. So it would be 1, 2, 4, 8, 16. Not this where I'm numbering from the left to the right. This is only for determining how many bits are we going to borrow. So now we're going to figure out what our subnet mask will be for each of these subnets. We know now that we're going to be borrowing 4 bits. So for the purpose of the subnet mask, that means we're going to put a 1 in those first 4, but the last 4 are still hosts, so they will have a 0 in them. Like we've already said about subnet mask, have zeros where the host goes, binary 1s where the network goes. So that gives us this one now. So now we'll look and see, and we'll see that 1, 2, 4, 8, that we've got a 1 in the 16s, the 32s, the 64s, and the 128s. So if we add that up, we're going to get 192, 224, 240. So actually our subnet mask will end in 240 for each of these subnets. So that's going to be the subnet mask then for it. Critical thing for you to remember right at the moment is that we're borrowing 4 bits and that we're going to be working with those 4 bits. So I'm not going to put the 192.168.4 up on the screens after this. We're going to assume that's there always in front of everything we're going to do in this problem. That we're just going to work with the last octets. That's the only thing that keeps changing. Any questions on this before I erase it? And remember, I am recording this so you can go back and look at it again. Here, you mean right here? That's 240. That's a 4. And the pad wants to turn angled on my lap sitting here. So sometimes that gets a little on it. Okay, yeah. I used a 4 up there, so that is a 4. That's supposed to be a 4 right there. It really doesn't make any difference to anything because that's just the first part of the address, and that's going to stay constant for us the whole time. And I'm not going to draw that one back up there again on it. We're going to assume everything I show you in the chart that we're going to start building in just a second. All of them start with 192.168.4 point whatever is that I put in the chart. So you only reverse on putting those values purely for deciding how many bits are you going to borrow if you've been given the number of subnets they want. If they told you they want so many hosts per subnet, we're not going to do that reversal. That's just for finding how many bits are we going to borrow when they tell us how many subnets they want. Okay, so otherwise, we're going to always do it correctly with the 1, 2, 4, 8, starting from the right, going to the left. But this one situation makes it easier if you'll do it in reverse. Instead of having to sit there and do it in the normal and then subtract it from 255 and see what the number you get is. Okay? So it makes it a quicker way on it. All right, I am going to go ahead and erase this. And then I'm going to start my chart, which is what we're really trying to build. So we're going to have a network address. I wish we remember what I was doing. So we're going to have a network address. We're going to have host addresses. And we're going to have a broadcast address. Your question that you may have on the test or whatever, or on a certification test, could well be, what is the third usable host on the fourth subnet? And so your object is to build this chart far enough to find what that number is. And that's what we're trying to build in here, is to find what will be the host numbers on each of our subnets that we will use on each of those subnets. So we're going to go with a simple little chart like this that I'm going to build from. And we're going to build rows across it. And we're going to build them all up here. Now, we said we're borrowing 4 bits. And that's just a little note to remind us up here is all I'm putting that there for. So for the first one, it's going to have, in the first 4 positions, it's actually got a 0, 0, 0 for, goes into the network portion right there. Because the first subnet will be the 0 subnet. The second one will increase by binary 1, which would be 0, 0, 0, 1. That's 3 zeros and a 1. The next one would be 0, 0, 1, 0. The following one would be 0, 0, 1, 1. And then you put the 4 additional numbers behind it, which on the network address, the host portion of the network address is all zeros. So for this first subnet, its number that goes in that 4th octet has 4 zeros to start with, and then it has 4 zeros in the last 4 bits. That will give me 8 zeros, which is what decimal number? That's a question for somebody to answer. Very good, Deidre. So our subnet number is 0. Okay, everybody see how I got that one? Now, I'm going to go over and do the broadcast next. I'm going to come back to the host because they're in the middle, and to me, the broadcast is a simple one for you to calculate too, and then the host gets a little bit harder, but it's not that hard. So the broadcast address, it will start with 0, 0, 0, 0 also, because that's that's the network address for this subnet. And then the broadcast address, remember, what does it have in for the host numbers? We talked about it earlier this week. It's got all binary 1s in the host portion. So it's going to have 4 1s in it. No, it's not going to be 255. That was where I warned y'all the other day. we were seeing 255s, but don't always depend on that. When you're working with the whole on the class basis, yes, 255. But in this case, it's not going to be, because we've only got 4 ones there, and we got 4 zeros in front of those 4 ones. 255 would be 8 ones. So we've got a 1 in the ones, a 1 in the twos, 1 in the fours, and 1 in the eights. So 8 plus 4 plus 2 plus 1 gives me what number? 15. So our broadcast address is 15. So now our actual broadcast full address is 192.168.4.15. Does everybody follow that part? Okay. Now, for the first host, we're going to put in here, it's going to start off again with the 000, because that's the network portion. And then the first host would be would start with number 1 in binary. So that's 0001. So if we look at that, that means our first host address is actually 1. And then our last one would be in binary 0000, 1, 1, 1, and 0, because it can't be all ones. It's got to be one less, because all ones is broadcast. So that number is going to turn out to be what number? Anybody got a quick answer for me? Nope, because that's closer, because that's a 1 in the twos, a 1 in the fours, and a 1 in the eights. And Cortez, you win the prize. Except I forgot to get any money out of the bank today, so you don't get anything. Sorry. So that's our first subnet. Oh, you're right. Did beat you. Okay. You don't get anything either. I didn't have any other money. All right, so that's the first subnet. Everybody follow how I did the first subnet here? The next one is going to work similar, except I'm not going to go real far on this one, and then I'm going to show you how you can cheat. So the network address ends in 0. It is the network address, the first part of it will be 0001, and then remember it follows 4 zeros. Okay, so that means the 1 is in the sixteens. Okay, because remember the 1, 2, 4, 8 all have 0 in them in the host portion for the network address. So that 1 right there is in the 16s column, so that means that the network address is 16. Y'all with me so far? Now while I'm doing this, start noticing if you see any patterns occurring. So now I'm going to do the broadcast again, just like I did on the other one, except it's going to be 0001 followed by 4 ones, because it's got 4 ones in the host portion. So now we've got a 1 in the ones, the twos, the fours, the eights, and the 16s. Well, if we add 16 plus 8 plus 4 plus 2 plus 1 together, according to my head, which last hour it made a mistake in, it should come to 31. Y'all agree on that? So our first usable host would be 0001, 0001. And that then is a 1 in the 1s and a 1 in the 16s, which gives us 17. For the ending one, it would be 0, 0, 0, 1, 1, 1, 1, 0. And that should give us 30. Okay? Now, with the information I have given you so far that we have drawn on here, if the question was, what's the second usable host address on the second subnet, what would the answer be? We've got it up there. Second usable host on the second subnet. And if that was the question, we wouldn't have to fill out this chart any further than what we've done. No, because 30 is not the second one. 17 is the first address. What's the next address? Correct, Deidre. 18. Okay? So you can count off whichever one it is, and you will get questions like that on the test and on certification exams. When I took Network Plus last fall, I had several questions pop up of what is the third usable host on the fifth subnet? And I had to do the chart down far enough till I got the fifth subnet and see what that range is, and then count them off. 17, 18. Okay, it's 18. So, and remember, when you take the test and when you do certification test, you can have a blank piece of paper with you with a pen and pencil to scribble on and draw all this stuff out on as you're working on it. So this is not something you have to do all in your head, okay? That you'll just write it out. Now, when you're taking the test, paper and pencil, okay? So yes, that would be the full address right there, Deidre. Very good. Okay, so all I'm showing you in the chart is just the last. You'll look in some books and you'll see they give you the whole address for every one of these, but you can real quickly see we would get buried in numbers on the screen, and besides that, I don't have enough space to do that in on here. So I'm dropping off the 192.168.4. We're assuming it's in front of everything. On a certification test, they will normally nowadays give you a marker board and a marker pen, and you can mark, erase, and when you finish, you just leave it there and they erase it. And so when you finish your test, you're supposed to destroy the piece of paper and not give it to your friend so that they know how to do the test then. Okay? Does everybody follow on that so far? Now, here's what I want to show you is, when I got taught this, we went on down all the way through this whole chart, calculating all of those numbers. Well, by the time we got to this next row, I started spieling off to the instructor as fast as he'd write out the number on there before he could even finish writing out the binary. I'd tell him what the answer was of what that number was going to be. And he's going, how do you get that calculated so fast? Because he'd sit there and convert from binary back to decimal. And I said, simple. There is a pattern up there on the board that we're looking at. And we're looking at the pattern right now. Because if you look here, what's this? 0 and then 16. 1 and 17. What's the relationship there? They both increased by 16. Now, this will vary according to the number of bits you're borrowing, so don't think that 16 is always the magic number. 16 is just the magic number when we're borrowing 4 bits, okay? 14 and 30, 16. 15 and 31, 16. So now we don't have to do all of this binary work to do the next row. We can go ahead and do it. Because what's the network address going to be? The network address, you jumped ahead of me, Deidre, I think. Because I think you're one column ahead of me at the moment. What am I going to put right here in network? And that sounds right. But what is it Very good, Cortez. You gave me the number I was looking for. And Deidre just wants me to think, so she's going to throw it at me in binary, figuring she's going to see if I really know my binary or not. All right, Deidre, what's the first usable host address? Correct. The last one will be that we're going to have 46, because 30 plus 16 is 46, and our broadcast address is 47. Now, also do pay attention to that broadcast is one higher than the highest usable host number, and that your network address is one less than your first usable host address. So notice there's all kinds of patterns in here. But 16, I'm going to come down here to the bottom and write it down here. That's our magic number, and you'll see places actually refer to it as a magic number now. That's run this whole chart for us. So if we needed the 7th row, all we got to do is real quick calculate here. There's the first 3. So then that would be the 48. That would be the 54, not the 54, the 64, if I'll add 16 correctly there. And then the 80s would be the next row, 3, 4, 5. And I said the 5th row, didn't I? So the 64 was as far as we needed to go. So we know 65 would be the next one on this, because in between here, we know that it is 49. And so we know the first one would be 65. And if we want to know the 5th one, that would be 65, 66, 67, 68, 69. So 69 would be my bit. Yes, you'll have a magic number in every chart. If you're borrowing, depending on how many bits you borrow, depends on what the magic number comes in at. But every time on these, there's a magic number there. So if you look at the charts in the book and look down through it, you'll see that it really has a magic number, but the book's not going to tell you about a magic number. That's something I'm introducing to you. Okay? And as a shortcut, and I think a really neat function on this. Okay? And I think they're just calling about my car warranty. It's coming from South Carolina, and that number might be something else. I don't know. But in any event, do y'all all catch that part on it? Do y'all see how that works on doing that magic number there on it, and how you, and that you don't have to sit here and draw out the whole chart to get to anything? First off, if you want to know about something in the 5th row, you only have to do the chart through the 5th row. You don't have to draw the whole chart out. I've had instructors try teaching me that you got to draw the whole chart to then be able to go back and find it. No, you don't need the whole chart. You just need to do enough of the chart to get to what you need. Don't do more work than you need to do, particularly on the test, because that's time consuming, and time is of essence when you're doing a certification test or a test. And shortcuts that we can learn are very helpful to you. Okay? Other questions on it? Okay, Deidre.
So under the 4 column, those are the different subnets, correct? And you, under the N column, you just gave them a decimal number?
So each of these, each line here is a subnet. Okay? We started working using the binary to do it, because you got to look back into the binary, because you're splitting that number down in the octet in half in this case, or how many ever bits you're borrowing. So you got to work from binary from it, and then you're putting it into decimal. And so these are decimal numbers. So
the subnet,
I don't know what that little line sitting there for, other than to confuse us.
So the first subnet address would be 192.168.4.0, and then you would have
That would be the first subnet network address.
and then the
Okay.
second one would be 192.168.4.16.
Yes.
Okay.
Dot 16. The first usable host on the first subnet would be the 192.168.4.1. And then you can use every number till you get to 14. So your usable numbers will be 1 through 14 on that subnet. So the highest one would be 192.168.4.14. And if you want it to broadcast something to all 14 of those machines, you'd use the address 192.168.4.15. Does that help? Okay, so that's the whole object of doing this. Because, all honesty, this was confusing to me when I did it originally, okay? When I was sitting in Morgantown, West Virginia, taking this Cisco class, this confused me for a little bit. And particularly, as I mentioned the other day, I had it in my mind about just 255s and zeros being subnetting. Did not realize what you could do with subnetting, how it got complicated. I just knew it purely on class bounds. This is what, when somebody says about doing subnetting, this is what they're talking about. And this is when somebody tells you that they find subnetting impossible. This is what they're talking about. However, in your case now, you don't find it impossible. That hopefully this has cleared it where you can now see on it. For me, seeing patterns in it and everything makes all the difference in the world. Okay? And seeing those patterns there makes it very much usable. Now, here's the other part I will mention to you again. IP version 6, you don't have to worry about this stuff in. So in a few more years, maybe 5 years, maybe 10 years, I'm not sure. I really think it's going to be more like 10 to 15, but I'm not always the best predictor. That will finally leave IP version 4 behind, and we'll quit fooling with this whole bit about subnetting in IP version 4. And then you don't have to know this stuff anymore. It'll be like where I can tell you certain codes on punched cards. Absolutely worthless information today, but when I was in college, it was useful information when the printing part of the card didn't work and it didn't print the character on the card, and you had to look at the holes and figure out what in the world was actually in those holes. But it's worthless now. So, but hopefully y'all can see the patterns and see the shortcuts. No. Neighbor discovery is what IP version 6 is going to use to keep track of everything. It's going to use that in place of ARP. So neighbor discovery relates to ARP, and it's the IP version 6 thing that does what ARP does in IP version 4. This is subnetting. There is subnetting in IP version 6, but when we get to it next chapter, next week, that I'm going to show you that it's real simple. You just choose which network number you want to assign to each subnet, and you've got a single hextet to assign those numbers in, and you can assign over 10,000 subnets to a network. So way over that, but I can't even remember the number in terms of, because it gets into hex. Is there a name for this chart? It's a subnetting chart. It would be the only thing I know it is. I don't really remember ever any specialized name for it, but it's just a chart of subnetting. And I know you're looking for a specific thing, but I don't remember ever hearing, this is just a chart showing our subnet addressing, our addressing for our subnets. All right, any other questions on this one? Because I want to real briefly attack this from the other direction. And you're going to see real quickly that there's just one little change to it, and then it works the same way. So I'm going to go ahead and erase this. And now we're going to do it. We did that based on you were told how many subnets you had. This one we're going to do based on you've been told that you are to have 5, whoops, pen's not working, 5 hosts per subnet. Okay? How many subnets that's going to make, we don't know. All we know is the requirement is we need to have it to allow for up to 5 hosts per subnet. Okay? Now, we're going to go the same direction. I'm going to change our address just to make it, to keep track of a different one instead of citing the same one that we've been citing. So I'm going to go with 14.x. So now to decide how many bits are we going to borrow for the subnets, we're going to again lay out our 8 bits. 4, 5, 6, 7, 8. But now instead of counting from the left, and remember I said that only applied for if they told you how many subnets they want. Now we've been told how many hosts, so that doesn't apply anymore. So we're going to go back to our normal routine of how we learned how to do binary with our numbering. Well, we're going to again count off and find how many bits do we need to handle this many hosts. And we're just going to add them up until we get a bigger number than this number we need here. You want to always allow for growth also. So if it did come precise on it, you probably want to use one more bit than what you found so far, because when somebody else buys another machine next week, you don't want to have to redo this whole thing to reset up your whole network. So here we got the 4s, the 2s, and the 1s. So that's 7 on it. So we know that that will allow us 7 hosts per, actually 6 hosts per subnet. Okay. Because the 0, remember, is the network, and all 1s is a broadcast, which would eliminate this 1 here. So we'd have 6 hosts per subnet. So we are going to divide it right here. So instead of like when we did before, we borrowed 4 bits. This time we're going to borrow 5 bits. But from here on, it works just like what we just did. So our first subnet is going to have the address of 5 zeros, and then the host portion is obviously zeros. So the first subnet is 0. The first broadcast address would be 5 zeros for the network, and then 3 1s, which if we add up is 1, 2, 4. So that's 6, that's 7. So there's our 7. Our first usable address would obviously be the 1, 2, 3, 4, 5, and then the 0, 0, 1. So that's obviously 1. And then our last usable one would be 5 zeros, followed by 1, 1, 0. Notice this is the same as we did before, so that's a 1 in the 2s and 1 in the 4s, so that's 6. So our second row will start off with 0, 0, 0, 0, 0, 1 for the network portion, followed by 3 zeros. So that 1 is going in the 4th place. So that's the 8th column that we can look back up here and just notice our column numbers and realize what's next. So that means that one's going to be 8. Anyone got a guess on what our magic number is at this point? Very good. Correct. So our first usable address on this subnet would be 9. Our second one would be 14. Our last one would be 14. And our broadcast would be 15. And then the next subnet would start with 16. And then obviously 17. And then 22. And then 23. And so notice it builds exactly the same way as what we went through on the other. The only difference is for when we've been given the number of hosts, we work from the right to find how many bits are we going to keep for the host, and then the other bits get on the network will borrow. Or if we know how many subnets we want, we'll work from the left in that unique counting situation, find our line, and then know how many bits the network is borrowing. Any questions on that one? But y'all follow where it follows exactly the same approach on it. Not exactly sure what you mean by that, Deidre.
Like the 6, 7, 8, 9, and then you find the host 14, 15, 16, 17, then you find the host 22, 23, 24 will be the next subnet number.
So
The first usable host
yeah,
is in the
it just keeps on, because the next subnet is just one higher than the broadcast and so on. And in this case, we'd have a whole bunch of these lines down here because we've got 1, 2, 4, 8, 16. We'll have about 31 subnets available to us. Okay. So this chart would be, if we did the whole chart, it would take up a whole lot of space to do.
You
But they
mean
just keep
31?
climbing, just climbing the same way.
You mean 31 available, but you're only needing 5 though, right?
There'd be 31 available subnets. Now, how many of them you actually use, I don't know. But the question that was given to us that we were working off of was that we got to have 5 hosts per subnet. So if we have 5 hosts on each subnet, or actually in this case 6, because it's got one more, because when you borrow that many, you automatically get that one more. That will allow you 31 subnets. Okay. If we had have said we need 31 subnets, we would have found out the number of hosts on each subnet was 6 addresses, usable addresses. So it just keeps on building right here until when you get through, you should finish up with a number down here at the bottom on the last one for the broadcast address should end up as 255. Do not go any bigger than 255 because that's impossible, because you can't go bigger than 255 and 1 byte. Any other questions? As y'all can see, we're running up on a full hour on this one. And y'all can see why I split this in 2 sessions this week. Y'all didn't want to listen to me for 2.5 hours. Okay. Now, if there's not any other questions on this, I've got that one last item I want to cover, and that's going to be pretty quick. So I'm going to wipe this out. And then I'm going to show you, if you're given an address, I keep forgetting to go turn the pin back on. So we're given an address 192.168.100.38. Let's go with 138. So we've got that address. We want to find out what's the network portion of that address. First thing is we got to know what is the subnet mask on it. And so we know, since this is a Class C address, it's got to be at least start off with 255.255. And then it was one that was subnetted, so it had some other address in here. So it had something like 190. We're going to go with 224. Okay. Now, the book takes the approach of teaching you to do this. So they'll sit there and convert this whole address into binary all the way across, all 32 bits. Convert this subnet mask all the way across 32 bits into binary. And then they go down and they AND everything to figure out what is the portion of that address that's actually the network portion. If that makes sense to you, feel free to use it. Doesn't make full sense to me, so I don't use it. I go this approach instead. That I look at this, well, I know this part already is a given to me, that is definitely network portion of the address. Our question is, here in the last octet, what is the network address out of that? Here's what I do to do this one. I will convert the 138 to binary. So 138 converted into binary is a 1 in the 128s. That leaves 10, so nothing goes in the 64s, nothing goes in the 32s, nothing goes in the 16s, but 1 goes in the 8s, which leaves 2, nothing goes in the 4s, and 1 goes in the 2s, and 0 in the 1s. Okay, so that should be 138 there. 1, 2, 4, 8, and 16, 32, 64, 128. 128 and 8 and 2 would be 138. Okay, I then take the subnet mask. So this was the actual address. So I'm going to put ADDR. Now this is the subnet mask. I'm going to convert that, the 224, to binary also. Well, 1 will go into 192. 192 will go into 224 once. That leaves 32. 64 won't, so that leaves 0. 32 will go into 32 once, and then we 0 it out. So we'll put a 0 in all of the other columns. Okay. So now that gives me my subnet mask, and I know looking at this subnet mask that we have borrowed 3 bits because it goes over to this 3rd position. So there's where my network address is in that left portion. So if I look up at this one, the only thing in the network area is there's a 1 in the first column, which would be the 128s. So my actual network address would be 192.168.100.128. And that's my network address for this given address. I effectively did the ANDing in there, but it didn't get complicated into how to do the ANDing. I just eliminated off on these, and where there was zeros down here, all trailing on it, that I then put, that won't work on second thought. That subnet mask doesn't work, sorry. Because that would be a 1 right there. So that address wasn't a good address in the first place. So we would have to add 64 to it which would be 202, and that would make this a 1 then, that my subnet mask should have been. Well, the 138 was fine, that I could have stayed with that correction. But my subnet mask shouldn't have been 224. It should have been a 1 in the 128 and the 160, and then 1 in the 64. I drew it wrong down here. That's what I did wrong, because 1 in the 128s, that left 96, 64 would have gone in 96 once. And so I should have had 1 here. So I had an error right there, correction. And then I would have had 32 left. So then that's correct. I made a mistake right there. Sorry about that, folks. And so my answer was correct. My address actually is 128 because the network address, because again, the line draws here because the ones stop here. It's got to be solid ones to the end of the ones, and then it's got to be solid zeros from there on out. So that's correct. And so then I just look at that and go, all right, solid ones to here. That's all I got to worry about right here. There's only a 1 in the 128, so there's my answer. So that's just a shortened way of doing around. You could do the ANDing also, but I tend to just look and go, I don't need to sit there and, which is where a 1 and a 1 gives you 1, I think, and a 1 and a 0 gives you 0, and a 0 and a 1 gives you 0, and you do that all the way across on it and then see what you got, which gives you the same thing that I ended up right here. What I did wrong was when I wrote this number out right here, for some reason I did my calculation wrong, that my subnet mask was 224. And so when I put the 1 in the 128s and subtract it, I should have gotten 96 at this point, and somehow I got 32. I got ahead of myself is what I did. So then a 1 would go in the 64s, subtract that, and then that leaves 32. So a 1 would go in the 32s column, subtract that, and we got 0, and we zero it on out from there. Sorry about the mistake on it. So you're only worried about do the subnet mask, and you're looking at just where the ones go to, and you stop at that point and then look up at your address and convert it to binary, and just look at the part that comes where there are ones in the subnet mask. The rest of it, treat it as all zeros. No, because the 128 column is our first column that we're really working with. Because remember, 8 bits to makes the byte, which is the length of the octet. Now, when we were doing our number conversions, I told you to go to 1 bigger as you were switching, just to make sure that you got that you had it covered correctly. But you really didn't use that column on it then. But you could put a 0 there if you want it, but it wouldn't make any difference to it. But that column doesn't exist as far as in the address, because there's only the 8 binary bits that makes up that 1 octet. Any other questions? If there's not, I'm going to wrap this up. I'll remind you again, if you attended this today or you attended one of the others, because people are listening by recording to this also. If you attended one of the 4 sessions that I did live this week for this class for 2451, you'll get credit for the discussion. You didn't have to attend 2, although I encouraged you to attend 2, or if nothing else, to listen to 2 of them, which could be the Monday session and one of the 2 sessions today on Wednesday, or the Tuesday session and one of the 2 sessions today, and it doesn't make any difference on those. I will try to transfer these tonight. Get them. I haven't moved any of the collaborate sessions this week yet on there, but I will try to do them shortly or this evening after church. I got church from 5 to 7 o'clock. But I'm going to run back up to the school, and I'll try to go ahead and upload these at that point on it. As far as problems to work on, the chapter I think has some examples. I had a booklet that Cisco gave me with all of these different problems in it. The only problem is I don't have the answers or the problems. Nobody has typed them up for me. I had a student write up all the answers a few years ago for me on it, but now with the ADA requirements, I can't just give y'all the written copies of it with the answers, and the typed ones have to be where they were typed and not where they actually gave me an illustration of the pages in PDF, where they did a printed it to a PDF instead of saving it as a PDF. And so I can't get you the answer. So I don't think for a couple of years now that that would really do y'all any good if I gave you just problems but gave you no answers. And I haven't had time to sit there and go through this 30-page book of about 15 examples on a page of both number conversions and subnetting. And the subnetting obviously really gets complicated on the amount of work that's got to be typed in and into a format, because we're talking about doing those entire tables that I just showed you the first part of the tables on just a little bit ago. But just study it some, realize y'all can pass the test without being able to really do the subnetting, but you need to get the concepts of the subnetting, have an understanding of it. The chances are you probably will not actually do it out there in the real world, but you might. I have had some students that ended up with a job where they did do subnetting on it. I have subnetted a few networks a few times. But the other one is there's a cheat way around this on subnetting that most people do nowadays for IP version 4 also is, remember, these are private addresses and that we've gone to all of this private addressing on it. So instead of using a 192 address for your private addresses on your network, you use a 10, and then you use the second octet to put your subnet numbers into there, and then you still got 2 octets to put host numbers into. And for most organizations, that's more than enough addresses all on it, and that makes it simple to do the subnetting. But you need to understand the concepts of subnetting, because that continues to be, by all of these people in networking, to be considered to be something really important that you really need to know how to do or know about doing, even though you probably aren't going to do it. In a few more years, knowing how to subnet in IP version 4, I say, is going to be obsolete. So don't bury yourself too much on it, but do see if you can catch the theory of it. And that was the idea of my overview on all of this, was for you to catch the overviews. All right, Deidre.
This is about the cabling sessions. We will be coming back at the end of the semester to do a final on it, correct?
No, I'm not
So
going
we're
to
just
have
doing
y'all
a
all
month.
in for that, because with given the continued craziness all semester, that there's no reports constant on the whole bit about the pandemic and everything, and then trying to arrange it all, I'm going to skip that one. That you are going to do a hands-on assignment that Cisco gives instead of coming back and doing those again. So this will be the one time you do the cabling for me. In the past, this would have been just an assignment midterm that was mandatory. So that's that. WMC is Whitfield Murray, which is over there in Dalton. CCC is Catoosa, which is in Ringgold. WCC is Walker, which is where I'm at in Rock Spring. GCC is Gordon, which is in Calhoun. FCC is Floyd, which is in Rome. And I had no request to go to Polk County, which would be PCC. So look at the schedule. I've managed to come up with a schedule based on what everybody sent me, that I managed to get everybody that I had a request from completely covered in that schedule. Now, I realize for some of you that some of your schedules have changed or whatever slightly since, and just look through there and see how best you can work with it. And if it absolutely will not work for you, let me know. And Catoosa is just about a mile or so off of I-75 up there at Ringgold. Whitfield Murray is sitting over more on the west side of Dalton, going around on the bypass around Dalton on the north side. But actually for Fort Oglethorpe, both the Rock Spring campus and the Ringgold campus, depending on where you are in Fort Oglethorpe, either one of them might be closer, because Walker is in Rock Spring, right down I-27, and then the Catoosa campus is sitting in Ringgold, and it's sitting there on the south side of Ringgold, right there just below I-75. It's sitting behind Zaxby's, if you know where Zaxby's is, across from the industrial park in Ringgold. The school sits right behind Zaxby's and the Hamilton Medical Clinic, and just one lot down from the Mountain View new dealership. Okay. So it just depends on where you're located at, which campus may be the closest one for you. Because I'm based at Walker. I used to work at the Catoosa one for a couple of years also, and I'm regularly up in Fort Oglethorpe and Ringgold, and so back roads and everything, there can be an even split between them all. Okay. Any other questions for me? If not, I'm stopping the recording. Actually, I'm going to stop my share first. I hope that helped y'all a whole lot. That was the whole idea of the session. And like I say, I know this is not something simple. I know it was difficult for me. I know it's difficult for most students. But once you catch it, you'll catch it. It's just that managing to finally see the light come on. And that was the magic number for me. For you, it may be something different, but hopefully I've clued you into something to help make this a little bit clearer for you. Because if you've read it in the book, you probably were totally confused. I get confused reading it now in the book. Okay, so I didn't use anything about the book while I did this whole lecture. This was purely off the top of my head, my approach. I didn't go from what they were teaching at all to it, other than I told you that they use the ANDing method. So I'm going to stop.